Hello everyone, and welcome to this first in a series of courses on Python 3 for advanced learners. In this course, you'll learn functional data processing in Python. This course is ideal for aspiring and experienced Python developers alike, those looking to deepen their understanding of Python through the lens of functional programming. For data engineers and analysts, professionals who manage and transform large datasets for a living, who may be seeking more efficient and readable coding methods, will also find this course particularly beneficial. This course is also aimed at software architects and designers, for those who design complex systems for a living and are interested in incorporating functional programming paradigms into their workflows. It's also beneficial for academic researchers in fields such as data science, computer science, mathematics, and any quantitative field really, where advanced Python skills for data analysis and algorithm development are required. And finally, above all else, anyone with a curiosity for Python and functional programming in general will benefit from this course. So whether you're looking to advance your career or personal growth, this course will provide valuable insights into modern programming techniques. Now, as this is an advanced course, there are certain prerequisites. The course assumes familiarity with Python syntax, including variables, loops, and basic data types such as strings, lists, and dictionaries. You'll also be expected to have an understanding of core programming concepts such as functions, loops, and conditionals, as well as defining and using functions in Python, including the use of parameters, arguments, and return values. Now, although the course focuses on functional programming, a foundational knowledge of Python's object-oriented features is beneficial for your progress in this course. Familiarity with Python's standard data structures such as lists, sets, and dictionaries, as well as their common operations, is also expected. The course also assumes a certain degree of problem-solving skills, specifically your ability to think logically and solve simple programming problems, as we'll build on these skills to enable you to solve more complex problems as you go through the course. And finally, your enthusiasm to learn is probably the most important prerequisite for progressing through this course. Let's now talk about what this course covers. We'll start off with functional programming, more specifically Python's functional programming tools, such as lambda, filter, map, and reduce. You'll understand how these built-in features facilitate functional programming techniques, helping you familiarize with Python's functional programming toolbox to streamline your code for data transformations down the line as we progress through the course. We'll follow that up with generator functions in Python, where you'll learn the concepts and mechanics of generator functions and the benefits of using them for memory-efficient data handling. As we progress through this section, we'll go through plenty of practical examples of generator functions in action and help you really master the creation and use of these for efficient data processing. With that knowledge in hand, we'll proceed towards functional data processing and analysis, where you'll learn techniques for picking subsets and summarizing information from collections functionally. You'll learn practical applications of using these techniques in data analysis, helping you apply them in practice to effectively process and analyze data. Building on this, we'll get into advanced uses of generators such as combining map and reduce for data transformations using generator expressions and complex data transformations. You'll explore advanced concepts like generator expressions and chaining generators and learn how to use them for complex data processing tasks. Armed with all that knowledge, we'll get straight into real-world applications and best practices, where you'll learn how to integrate all the functional programming concepts you've learned in real-world scenarios. The three we've chosen for this course are streaming log processing, genome sequence detection, and stock price anomaly detection. We'll discuss best practices in Python functional programming as we progress through these examples, equipping you with the knowledge necessary to apply functional programming techniques in real-world applications effectively. Therefore, by the end of this course, you'll have learned functional programming, how to craft concise, expressive functions for efficient data handling. You'll have learned functional synergy, or how to combine simple functions to create more eloquent and succinct code than lengthy procedural code or complex object methods. You'll have developed an appreciation for functional versus procedural or object-oriented programming through a thorough understanding of when to consider functional versus procedural programming, and therefore inform your approach to software design in general. You'll also have learned how quantitative and computational methods translate into Python programming, forming complex results through simple combined transformations. You'll delve into the core patterns of mapping, filtering, and reducing data, applying, selecting, and summarizing datasets through functional paradigms. You'll have gotten comfortable with Python's functional toolbox, built-in higher-order functions like map, filter, and reduce, along with the itertools module for versatile data processing tasks. You'll also learn how to use immutable name tuples, frozen data classes, and mutable data classes for stronger type checking and clarity in your Python code. And finally, in the real-world examples section, as we covered earlier, you'll take everything you've learned and go hands-on with generator functions, applying transformations, filtering subsets, and processing data within collections of different types in practical real-world scenarios. So without further ado, let's get started.